Good morning, Algebra 2. Wow, it's another class time. And today we get to start chapter 14. And if you preview the section, it's only 2 sections. But there's a lot of interesting and applicable information that we can deal with, because chapter 14 is going to take exponential functions and other functions that we have learned throughout the year, specifically growth functions, decay functions, quadratic functions, and linear functions. And we're going to take that and see how that works in the real world, okay? So again, I think you'll like this section. We're going to do this section in 2 different ways. We're going to do it algebraically, and then we're going to show you how to use your calculator on specific modeling techniques. Okay, so the first thing we'll do is we're going to look at section 14-1. And the thing that section 14-1 is dealing with is fitting exponential functions to data. So in other words, we're going to be giving a set of data that's going to be specifically designed for exponential functions, whether that function is a decay or whether that function is a growth. And we're going to be using this main formula right here. This one is very familiar to us. You're going to see how we're going to do this. Now, section 14-1, I'm going to do this in 2 videos. The first video, I'm going to focus on the information that deals with the explore part. Again, if we have a good grasp of what the explore is about, when we get to parts of 14.1 and parts of 14.2, it'll be you'll have a good grasp of what we're talking about. So like I said, we're doing this in 2 parts. First part is looking at the explore. The second part is we're going to take our set of data, we're going to create our exponential function based upon our data, and we're going to do it algebraically, and then I'm going to show you how to use your calculator, okay? And pretty much for the rest of the year, if you know how to use your calculator, you're going to have no problem doing this section. All right, so let's get started. So section 14-1, part 1, again, fitting exponential functions to data that's been given to us. And the first thing we'll do is, like I said, we're going to do the explore part. So the explore part is just identifying what is an exponential function just from tables of values. All right, now again, this is some of the stuff on here I'll probably have to come back on and talk later, but that's okay. I'm going to do it right now, okay? The one thing that I've highlighted right off the bat is the very last sentence and a half, okay? And it says this: the ratio between the successive values of our function is going to be our value of b. So again, if you go back and think, what we're trying to do is we are going to try to take our data, and our goal is to create this specific exponential function. And right off the bat, the ratio between the 2 function of value is going to be our b value, okay? Now, it's got to be certain ways, okay? I'll show it to you. Now, the last sentence is this gives you a test to apply a given set of data to see whether it represents exponential growth or exponential decay. Now, again, going back, this b right here, remember now, if b is greater than 0, you're going to have an exponential growth. Now, if that b is between 0 and 1, you're going to have an exponential decay. That is something that we talked about or dealt with in the last chapter. All right, so a lot of information here, so just hang on, okay? So the first thing we're going to do is let's look at Explore A. And I'm going to tie in some stuff that we dealt with a couple of chapters ago. Here is our set of data. We notice that when x is 0, our functional value, or y, is 1. When x is 1, y is 4. You can see the table. Now, if you look at this bottom row, okay, we did this a long time ago. That is your sequence. And your sequence can tell you what type of function you're dealing with. We did this in a previous section, so I'm not going to focus on that. But what we want to do now here is look at what they're talking about here in this second, the last part of that second to last sentence, the ratio between successive values. So if I look here, if I go f of 1 divided by f of 0, in other words, 4 divided by 1, I get 4. Or 16 divided by 4, I get 4. And 64 divided by 16, I get 4. 256 divided by 64, I get 4. And you're going to notice that your ratios are all the same. So this tells us right off the bat, our data is an exponential function. As a matter of fact, it's a growth exponential function because you notice your growth is increasing. All right? We'll talk about what this looks like graphically in the next video. All right, let's look at letter B. Again, now, once again, I didn't share with you at the beginning of this video, but pause the video before we go on to the next one and see if you can work it out yourself, okay? So if I go to the next letter B, once again, here is our set of data. And we're going to notice here that our sequence is 1, 7, 13, 19, and 25. But right off the bat, we see that our ratio from, like we did in example A, our ratio is not the same. So this is not an exponential function. So the next question we got to ask ourselves, which is very important, especially when we get into section 14-2, is if this is not exponential, what type of a function is this? Is it quadratic or is it linear? That's the key, okay? There's other types, but we're just focusing on the simple ones. So what I'm going to do is, even though this is not part of the section, what I'm going to do is over here to the right is I took the set of data, put it up as a t-graph, and I notice from our sequence of numbers, they all increase by 6. You with me? So that in the back of my mind already, I know that this is a or an arithmetic sequence. Now, since I know that it's an arithmetic sequence, it's not going to be an exponential function and it's not going to be a quadratic function. So this is an example of a linear function. Now I'm going to put that in a different color because it has some significance in a later section. So this right off the bat tells me that this is a linear function. Okay. First one, it's going to be an exponential function because the ratios of successive y values are all the same. Here, this right here on the letter B, that is not, they do not have the same common ratio or the ratio, okay? So it's not exponential. So the question is this, well, what kind of function is this? Well, based upon what I just showed you, this is an arithmetic sequence. So it's going to have to be, in our example, this is going to be a linear function. So that tells us our model will be looking like a linear function or a straight line. This one's going to look like an exponential. All right, now pause the video and try your hand at letter C. All right, letter C, same thing again. Take the time and look at your ratios. Once again, they are not the same. So this is not an example of an exponential function. So your brain saying, well, if it's not an exponential function, is it going to be linear or is it going to be quadratic? Well, the next thing you do is you take your sequence, which is 1, 4, 13, 28, and 49, and we notice that if we look at what's happening from one term to the other, it's increasing by 3. 3, 9, 15, 20. So right off the bat, this is not a linear function because if you go back up to example B, and since all our values increase by 6, that's going to make it a linear function. All right, so we know that these are not the same, have the same value. So let's go to the next one. So the next one is looking at the sequence 3, 9, 15, and 20, 21. They all are increasing by 6, okay? And since this is what they would call the second difference of your function, this one is an example of a geometric sequence, but now this one is going to be a quadratic. Now again, I'm bringing this up to you now because we're going to talk about, we'll probably have to see it again, okay? We'll see it again in the next section, all right? Now, once again, like I said, we are just focusing on this part, section 14.1. We're just focusing on exponential functions. So A, B, and C are 3 different types. All right, I want you to stop the video, and I want you to go and I want you to do letter D. All right, letter D now. You're back to the video. Letter D now. We see all our y values. If we go ahead and do the successive values of the functional values, we see that our data here is all have the same common ratio. So this is an example of an exponential function, but more importantly, it's a decay function because your y values are decreasing in value. All right, now I threw a lot of information at you. We're going to come back to that thought maybe in the next section. So video 2 now is going to take examples like number A and number D. Try to find this function based upon our data. And I've already shared already, we found what our B is. Okay, so letter A, our B is 4. And we got to find out what A is. So if you look at the letter D, we found out our B is 1/4. We just need to find out what A is. And we're going to talk about that in the next section. Okay, so 14-1, fitting exponential functions to data. We're going to do this now using our graphing calculator. We'll do it algebraically, and then I'm going to show it to you as using your graphing calculator. All right, guys. Thank you very much. We'll catch you on the next video. Bye.